education.
Greetings, travelers! My name is Mike. You've clicked on Earthshine Education. This is our Friday installation of, Friday, May 8th installation of 3 o'clock coffee. We do this once a week where we sit down, look at some articles that we find interesting about astrophysics, astronomy, earth sciences, space sciences, anything that we find interesting we'll talk about. I think last week we even talked a little bit about a weather application, an applet that I found. So it's kind of a free-form thing. We sit back, we call it 3 o'clock coffee because, well, you can sit back and have a little coffee and maybe some crackers and tea, or tea, I should say. I myself currently am drinking some green tea, so sit back, grab something to drink. Let's talk a little bit about some science. Excuse my mouse appearing real fast. Just want to make sure I'm in the right spot. There we go. So, talking about the moon. Yeah, again, last night was the full moon. This first article is actually coming from Forbes. You can find a bunch of these floating around if you type in flower moon, which is the name of the May moon. Every full moon has a different name, and I'm actually going to do a video on that coming up pretty soon. There's a wolf moon, there's a flower moon, there's a snow moon, there's a strawberry moon. Different moons, different moon names for the same exact moon. It's just a different month, and they have something to do with kind of what's going on. So obviously a snow moon's going to be in the dead of winter. That's in February. Wolf moon's in January. This month happens to be the flower moon. And this article I just wanted to kind of share because it's got some really cool photos from around the world. Everybody got to see a full moon, hopefully. Hopefully you had clear skies to see the moon. But that's kind of cool to see the Statue of Liberty with the moon instead of a torch in her hand. Again, just really, really cool to see people going out and taking pictures of the moon. I know things are a little wonky. Hopefully people had their masks on when they went outside to take pictures of the moon. But I'll leave a link for this. Again, all these articles will be linked down below. But again, beautiful pictures. Never a bad thing to share. Since we're talking about the moon, I'm also going to link the following two things. This is something that I talk about every month in our monthly sky updates, but it's about the phases of the moon. This is a NASA app built into the web to a website, so you can look at it through your web browser. What is the current phase of the moon is the name of it, and it'll actually go by whatever date you put. I'm actually going to cycle back and forth to kind of show you going back to the 23rd of April, which is when we had the new moon. You can go day by day, click by click if you want, to go through the phases, and it actually names the phases for you, and then it'll actually go all the way into the future and show you back to new moon phase. And if you click today, it resets it right back to the original spot, which is of course the day that you clicked on it. A little bit about eclipses, lunar eclipses, and then how the moon goes around our planet Earth. I'm going to make something of our own doing just a few weeks from now. On the moon, so be on the lookout for that. I will link this down below, including this other applet NASA has. This one actually has an interactive lunar surface. You can actually grab it and rotate it. It moves very fast, so be really gentle with your mouse motion. You can look at it from the top, you can look at it from the bottom. This is the south pole of the moon. This is the north pole of the moon. Now, this app is also very interesting because it's tied into the previous app, and it shows exactly the moon phase of that evening that you have to click on it. So I'm clicking on it on a full moon phase because last night was full moon. If I clicked on it in a couple weeks when it's a new moon, all of this would be dark and all of this would be light because this is the back side, or the quote-unquote dark side of the moon. This is the far side of the moon we don't see. The moon is what's called tidally locked, and we always keep this face looking towards us. And just interesting to see this little interactive applet. Lots of little tools on the right side. Lots of data points you can click on. You can also click on places where moon landings occurred. And then click back. Again, really, really cool interactive map. Apollo 11, click back here. A little bit about it. Even these other landers, robotic landers, they were non-human landings first, of course. And, you know, unfortunately, we don't have other landers from other countries on here. China recently landed a rover on the moon as well. And so these are all the American landings, which is fine. There's just lots of science going on here. Anyway, just wanted to kind of give you an idea of what's available out there when you want to learn about the moon. Also, you'll note the counter is only 24 humans that have visited the moon. Hoping we'd all be, at least have a base on the moon, be living on the moon by now, be whalers on the moon. Guess not. There's no whales on the moon, of course not. Scooting right along, unless you watch Futurama, then it's something else. Alright, moving right along. Speaking of interesting things, we're looking at something called Hayabusa. Actually Hayabusa2 is the name of this orbiter. The Japanese sent a probe out to find an asteroid called Ryugu, and it was an interesting proposition. The idea was to actually get a lander on the surface of this thing, try to disturb the surface, see how it would actually do, and then try to bring some piece of it back. Well, it worked. The actual lander won't be back till December of this year, 2020. But you can actually see this little lander thing going down and landing on the surface of an asteroid. I can't full screen it because I already have the browser in full screen mode, but I will leave a link for this so you can take a look at these videos. Really kind of interesting to see. Again, this is the surface of an asteroid. Interestingly enough, there's evidence that this asteroid may have actually gotten closer to the sun. Certain things may have melted in its past, and then it somehow was gravitationally pulled back outwards. Again, its orbit's very interesting, and so that's why it's actually being studied. I will actually drop a link for this down below. Again, a couple of videos are embedded in this website. But if you'd like to go to the source of it all, or the horse's mouth, if you want to go that way, you can actually visit the Hayabusa2 website, which I will leave down below. It is run by the Japanese, but there are English versions of the website. And if you have a keen eye, you may have noticed someone, a rock and roller, very famous in that brief little moment there. If you didn't, let's see here. It should cycle around. There's, again, what the whole point was, to go and visit and see what was on the surface of this asteroid, discover a little bit more about our solar system. There we go, Brian May. That is Brian May, Dr. Brian May, guitarist for the band Queen. He is a doctor in astrophysics. If you didn't know that, now you know. Really kind of a cool thing. You can actually read his research paper on the internets. A man I've never met, but I would love to meet, talk music, talk astronomy as well. But he's actually pretty interested in this Hayabusa mission. He's actually done some imaging of the asteroid, which is pretty cool. So, rock star and astrophysicist. I feel a little inadequate, but it's something I want to be one day. Who knows? Moving on to our next subject. What do we got here? An interesting little thing. Something that we really don't know, and you'll see right here, one of the greatest mysteries of modern astronomy. What is an FRB? A fast radio burst. We don't really know what these things are. They happen every now and then in really distant galaxies, and it's when radio waves just burst forth from some little area, probably from where a star used to be, or is, no one's really sure. Kind of pinpointing it down more towards what are called magnetars, which are really, really highly magnetic versions of a neutron star. Now, neutron stars are not stars in the general sense that you would think of. If you think of our sun, the sun is a ball of gas, hydrogen, helium, lots of plasma, I should say, as well, and hydrogen, helium, a little bit of lithium, carbon eventually forming in its core when it gets super old. And it'll actually kind of grow into a big, what we call a red giant star. The outer layers turn red, start cooling off, and, well, eventually it'll just die. It'll consume most of the solar system, and the outer layers of it will likely just kind of float away from what's called a white dwarf. In this case, we're probably talking about a star much larger than the sun, more massive, 10, 15 times bigger than the sun, so to speak. And when it dies, instead of it slowly kind of letting its outer layers out, it actually collapses in on itself. And everything inside of the core, which at that point is going to have lots of heavier elements, all the atoms will kind of fuse together with the electrons around it. So you got protons, neutrons, and electrons, the three main components of an atom. Well, the protons, the positively charged ones in the middle of the atom, will get fused with the electrons, I should say, that are encircling it, and they'll become a neutral particle. So we call it a neutron star. It's just a big ball of neutrons. Some of them seem to be really, really magnetic. No one's really sure how this all works. These magnetars are super dangerous. If you were to get close to it, your electrons in your body would likely get pulled in, especially these magnetars. You'd basically dissolve if you're within 1,000 kilometers of it. So probably not a good thing to be too close. Now, these things are pretty small. They're only about 20-25 kilometers in width, and they're not very close to us. Now, this particular one is interesting because it's been decided, it's been kind of, pinpointed to be somewhere within our own Milky Way, on the other side of the Milky Way. And that's kind of a new thing. This is kind of a cutting-edge astronomy thing. No one's really sure about what these fast radio bursts are. There are radio bursts coming from various areas of the galaxy and throughout the universe itself. And, well, some of them we understand, some of them we don't. This is one that we really don't yet. And so I can't really give you too much great information because I myself don't have that information. I'll leave a link to this in the description box down below, and we'll talk a little bit about it probably in the future. Don't want to dwell too much on it, but again, magnetar is a very interesting thing. We'll probably do a piece on that when we start doing our Astronomy 101 stuff. So eventually we'll have something here. Closely related, in a way, is, again, when stars collapse, they can become what's called a neutron star, which we just talked about. Some of them are magnetars if they're super, super magnetic. Well, if they collapse even more, they can become what's called a black hole. And black holes are really, really intriguing. You can't technically see a black hole. This right here, this image is of a artist's rendition of a black hole. And what's interesting about black holes is that, well, light can't escape them. But light can go around them in a way. It gets bent. And that's actually one of the ways we find black holes. You can actually see light being bent around it. You'll see light distorted around these black holes. They bend space-time. Hypothetically, it's dividing by zero if you can do the math. It just goes on for infinity. So what happens when you pass what's called the event horizon and you enter a black hole? Does time stop? Do you get stretched out like a big spaghetti? Probably so. What happens? No one's really sure. It's all lots of mathematics and conjecture. We don't really know what's inside of a black hole, but we do know we can find them and at least mark them on our sky charts. This particular one is looking at a star system about 1,000 light years away. You can't see it in the northern hemisphere, but in the southern hemisphere you can see about where this thing would be in the sky. It's in the constellation Telescopium, the telescope. Yes, that's the name of a constellation. Some of the constellations are, of course, ancient. You've got gods, you've got goddesses, Hercules, you've got great heroes, all these cool constellations in the sky. And then you've got things like a triangle or a telescope. It happens. Anyway, southern hemisphere, you can see this is actually done from a Chilean observatory up in the mountains of Chile. You got a lot of telescopes because they are very, very tall mountains. You do, I believe, need to take oxygen tanks when you go up there because they're up so high, which means there's less atmosphere to look through, less atmosphere to breathe for you, but you're less atmosphere to look through for the telescope. So it makes for clearer pictures. I will leave a link to the article that's in front of us here, as well as to this right down here. We're looking at an actual scientific paper. This is actually the paper that refers to the black hole we were just talking about. It's got a very technical title, of course, a naked-eye triple system with a non-accreting black hole in the inner binary. Okay. What that means is that the black hole doesn't have what's called an accretion disk. Sometimes black holes will eat up material around them. They'll either eat up stars or maybe planets, whatever happens to be nearby. It breaks them all apart and it starts making what's called an accretion disk. It's a flattened out disk of gases and dusts all around its equator, so to speak. and it'll have a big ray shooting out of the north and south spinning pole of it. Well, this one doesn't have that, so it hasn't consumed anything. Anyway, you can actually read a little bit about this. You can actually read the abstract and actually read the science behind this for yourself. This is actually what usual astronomy papers and a lot of these technical papers that go into scientific journals look like, which leads us to our next and final subject, which is this, archive. Now, archive's kind of held in 2 or 3 different places, but this one's archive.org, arxiv.org. This one's held through Cornell, and I wanted to bring this up because if you're interested in going down a rabbit hole, some people do that with, various websites, YouTube, Wikipedia, whatever you want to call it, and they just start watching videos or reading articles and learning, and they'll click another link, then click another link. This one is one if you want to be kind of learning about some of the newer sciences out there. This is archive, and newer research out there, I should say. This is archive, and it's got just about 2 million scholarly articles. 1.69 million, we'll call it like that. And they're all in different subjects. So if you have an interest in physics or astrophysics, look under the physics tab and you'll see astrophysics, condensed matter, relativity, high energy physics, mathematical physics, all this stuff. You just click it and it brings up another link to more articles. If you know a particular person you want to look for, or a certain scientist, you can actually search by their name, find all the articles that have their name connected to it. Computer science, statistics, economics. There's mostly geared more towards physics and astrophysics, but there are some other things available. I'm just going to click astrophysics, and as you can see, it just kind of brings up a little link. You can go back all the way to 1992. I'm just going to click new just to kind of show what's out there right now. Like, these are literally popping up in the last few weeks. New submissions for Friday, May 8th. Okay, cool. So these are actually brand new submissions that have just appeared. These are not peer-reviewed by the website or the holders of archive, but these are then going to get peer-reviewed as they go into, Astrophysical Journal and, all these, Science and Nature, all these different peer-reviewed journals that go out on a quarterly basis or sometimes on a monthly basis. They all start out here, or they all get archived here, I should say. If you want to learn more about it, you can actually just click on the link and it'll bring up usually a little bit of an abstract. It'll tell you about the different authors that helped write the paper, what they were studying, what the purpose of the paper is. A lot of them are just going to have a little thing up here. Just download a PDF. They sometimes do take a little bit of time. Let's see. This one doesn't take too long. I had one that took a little while earlier. So you can actually download these research papers. Like, these are actual research papers by PhDs and PhDs with master's students with them. Depends on what you're looking for. Just kind of an interesting thing. This is how science is being done around the entire world by various universities. And again, it'll have links to who these people are. It tells you where, which school they're from. There we go. That's much better. I happen to click on one that has someone from MIT, it looks like. Yeah, MIT. There we go. And then someone from Caltech. So this particular article, if I was interested in learning about white dwarfs, there we go. White dwarf binaries, I should say. And you could just click on it, read it all you want. Some of them might actually even have emails to these researchers, and you can actually email them directly. How do I get out of here? Oh, well. Yeah, that's it. Just wanted to talk about archive and how it works and what you can get. I will leave a link for it down below. You can learn all you'd like on your own. You don't necessarily have to go to school to do this. Obviously, if you want to do research, you will have to go to, a university and stuff like that. But if you just want to read up on other people's research right now, maybe find something you're interested in, who knows? This one's talking about emissions coming from a starburst galaxy. I'm just going to click it just to take a look. Again, I haven't actually looked through all these because these are brand new, and there's lots of them. Again, most abstracts kind of start out with the same way, same style formatting, and then you can see it looks like they've actually got some data from their observations, so that's always kind of an interesting thing. You can learn a lot by just clicking on these things, reading through these papers. If you don't know what these equations are, they're usually explained as you go along. If not, we'll talk about some of the more common equations in various Astronomy 101 things that we'll be talking about. But some of these things, they look very, very strange. You can always contact these researchers and ask them, what exactly are you talking about? How did this work? It's always kind of a cool thing, because a lot of them really like to talk about what they've been researching and how they've been doing it. Yeah. Anything else you need to talk about? No, that's it. Probably gone for way too long. Anyway, we appreciate you clicking on this link and watching this video. Appreciate you even giving us your time. I know they've got many, many other things you could be doing, and instead you clicked on this. So, I hope you have a wonderful weekend. Try to go outside and take a look at the stars, take a look at the moon this weekend. We'll come back next week with some fresh articles for the week. Also, if you haven't already done it, please click on our monthly sky update. We have one for May. Unfortunately, you did miss a little bit of a meteor shower, and you did miss the full moon, but there are some planets in the sky. Mercury will be popping up in the western sky later in the month. Venus is still in the west. Morning has Mars, Jupiter, and Saturn. If you want to learn how to find them, again, click on that sky update. Take a look at it. We appreciate your time. Have a wonderful afternoon and a great weekend. Stay safe out there. Take care.